Bismillahirrahmanirrahim. So this is the fourth lecture of the course Statistics and Probability Theory. In previous two lectures, we have discussed presentation of data, in which we have discussed how to construct a frequency distribution, how to make a histogram, how to make a bar chart, and how to make a multiple bar chart, and how to construct a frequency distribution of discrete data. So basically we have learned up till now how to represent the data. Now we will go to the analysis phase of our data, as we know that statistics is an art or science used for the collection, presentation, analysis, and interpretation of numerical data. Now the analysis of the data has started. At very first step for the analysis, we have to find the measure of central tendency. So what is the measure of central tendency? A single value which represents the whole data set. It is also called average or measure of location. So basically a single value which represents the whole data set is called an average, and this is the situation. Let's suppose these are the data points. All these in black colors are the data points in your data set. This is point number 1, point number 2, point number 3, and all are some numerical values. So if you are asked that how to represent this data set in a single value, so this red dot represents the whole data set, as this is the center of the data, and concentration of the data lies on this particular point. So this is the central tendency in which the whole data set rely. Basically this point is representing the whole data set. If we do this in numerical example, let's suppose that there are 4 students, and we have their marks of exam in the course of statistics. As each student has his individual marks, so the marks are variable, we represent it with X. Let's suppose the first student attained the marks 3 out of 5, and the next one have mark 4, the very next one has 0, and this one has 2. So this is basically the data set. It is the numerical values, and these are the marks of 4 students in a particular exam. So it is asked that represent this whole data set through a single value. So what we will do, we have to find any single value which represents this whole data set. So how to find that single value? There are basically 5 measures of central tendency. It means that there are 5 ways in which you can find out this single value which represents the whole data set. The most frequently or most common measure of central tendencies are mean, median, and mode, and mean could be found out by the way of arithmetic mean, it could be geometric mean, and it could be found out through the harmonic mean. So these are the 5 measures of central tendencies, and the most common are mean, median, and mode. How to find out the mean? This is basically the arithmetic mean. If I write it here, This is basically the formula of the arithmetic mean, and this formula is for the ungrouped data. Arithmetic mean. So the technique to find out the mean, arithmetic mean, is sum of all values divided by total number of values. So if this is the data and we want to find out the single value which represents the whole data set, so we could find out this is 3 plus 4 plus 0 plus 2 divided by 4. This is the way to find out the arithmetic mean, and it will give us a single value which represents this whole data set. And median is equal to middle value when the data are arranged in order, and mod is equal to most common value. As mod is a French word and it means the fashion, it means the something which occur more frequently. So mod is equal to most common value. So let's suppose you have plants in a room, and these are the height of plants in inches. So this is 4 inches, 3 inches, 1 inch, 6, 1 and 7. You have 6 plants in a room, and these are the heights of the plants. So you have basically 3 measure of central tendencies which are frequently used, which is average, which is arithmetic mean, median and mod. At very first step we will find out the arithmetic mean. So as you know, the arithmetic mean is find out by sum of all values divided by total number of values. It would be 4 plus 3 plus 1 plus 6 plus 1 plus 7 divided by 6. So this would be equal to 3.67 approximately. So this is the single value which represents this whole data set. Keep in mind that this is the way to find out the arithmetic mean for ungrouped data. As this is the ungrouped data. Ungrouped data means that we have not affected the frequency distribution here, and we are just dealing with the values of the data set. So how to find out the median? To find out the median, at very first step, arrange the data set in ascending or descending order. I have arranged the data set in ascending order. So the very first value is 1, second value is also 1, third value is 3, and 4, then 6, then 7. Now, if you want to find out the median, there will be two cases. One is the way to find out median when your number of data points are odd numbers. And one is the way to find out median when your number of data points are odd. For example, in this particular case, you have total 6 data points, 4, 3, 1, 6, 1, 7. So here you have n is equal to 6. So the number of data points are even, so the median will be arithmetic mean of the middle two data points of the data set. So as these are 6 values and middle two data points are this 3 and 4. So the median will be, this is the way to represent the median, and when you represent it by x bar, this would be arithmetic mean. So it will be arithmetic mean of the middle two values. Arithmetic mean is find out by adding the values and divided by the total number of observations. You have two values, 3 plus 4 divided by 2. This would be 7 divided by 2, and this will be 3.5. So this is the median of this data set, which is 3.5, and you can see this is as close to the arithmetic mean, which was 3.67. So this is the way to find out mean and median. If you represent this data set with x, if I named it with the variable x, so and these are the data points. Let's say this one is x1, small x1. This one is x2, up to so on. The number of values we have 6 values, so we will go to the x6. So if you write it in this way, this will be x1 plus x2 plus up to so on plus x6, as we have total 6 observations. So we will divide it with 6. This would be equal to summation I is equal to 1 to 6 into xi divided by 4 divided by 6. So this is the way to represent the arithmetic mean. As I have started the arithmetic mean by taking a numerical data set, if you want to represent it without the help of the numerical data set, so this is the way to represent the arithmetic mean, which is x bar. As we have taken 6 data points, you can have more than 6 data points. It could be 7, it could be 8, it could be 10. Let's suppose they are n. We are generalizing it. And in the case of n observations, this would be equal to summation I is equal to 1 to n, and one is xi whole divided by n. So this is basically the arithmetic mean. And in this case, as we have discussed the arithmetic mean for the case of the number of observations are even. What will happen if the number of observations are odd? Let's suppose we have 5 observations. Let's suppose this 7 is not here, then this would be 1, 1, 3, 4, and 6. In this case, when number of observations are odd, where this n is equal to 5, first of all arrange the dataset in ascending or descending order. Then the middle value will be the median, as this is 1, 1, 3, 4, 6. So this 3 is the middle value. So mod will be equal to 3. So this is the way to calculate the median in the case when the number of observations are odd, and this is the way to calculate the median when the number of observations are even. And this is our arithmetic mean. how to calculate the mod? We represent mod by in this way, and as mod is the most frequent value which comes most frequently in the data, if we concentrate on the data which is 4, 3, 1, 6, 1 and 7, if you concentrate on the data, this 1 is coming 2 times in the data, 4 is coming 1 time, 3 is coming 1 time, 6 is coming 1 time, and 7 is also coming 1 time. So each value is coming only once in a data, only 1 is coming twice in a data. So if we define mod, this is the most common value. So the mod of the data is 1. Keep in mind that there could be more than one mod in the data, and it is also possible that there is no mod in the data. So mod is the most frequent data point. Mod exists as a data point unaffected by extreme values, useful for qualitative data, may have more than one value, as I have said already that there could be more than one mod in the data. Median value that divides ranked data points into half, that is 50% larger than it and 50% smaller, may not exist as a data point in the set. As you can see that the median is 3.5 in this case. So this 3.5 is not in the data set. So this could happen that the mod could not exist in the data set. Influenced by position of items but not their values. It influenced by the position of values, as we always take the middle values of the data set. If it is even, then we will take the arithmetic mean of middle two values, and if it is odd, we will take the middle value of the data set. Mean is equal to x is equal to summation x over n, most stable measure affected by extreme value. This one is the most stable measure. Mean is basically the arithmetic mean. It is most stable value, most stable measure of central tendency, but it always affected by the extreme values, may not exist as a data point in the data set. As you can see that the mean is 3.67 and this is not in the data set, so it could happen that may not exist as a data point. But what is this? Affected by extreme values. What does it mean? So what is happening? These are all closely related 4, 3, 1, 6, 1, 7, but this 30 is far much bigger than all these data points. So what will be the new mean now of the data? It would be sum of all the values divided by the total number of values, which will be 4 plus 3 plus 1 plus 6 plus 1 plus 7 plus 30, and this time we will divide it with 7 as we have added the number 30. So the mean is 7.43. So this is the value which is representing the whole data set. But as you can see that all the data points are closely related, and only this one extreme value is coming, and it greatly affected the arithmetic mean, which is 7.47. As you can see that no value is between 7 and 30, and arithmetic mean is coming here somewhere close to 7, and it is far away from the all other values. Whereas if you go to this, part, as we have find out the arithmetic mean 3.67, it would be exactly somewhere at the middle of the data 3.67, and it is representing the whole data set, but this is 7.47. It means that on average the plants have the height 7.47, which is not true. So by adding the extreme value, the arithmetic mean is highly affected, and the result is manipulated, and it have taken you far away from the true value. So if the arithmetic mean, either the extreme value added is extremely high or extremely low from the data points, in both cases arithmetic mean will be affected. So as this is written here that affected by extreme values, then this is the case that arithmetic mean could will lead you to the wrong results. But this will not happen in median and mod, as we know that median is the middle value and extreme value will always come on the extreme right or extreme left. It could be very small or very large, and mod is always the most frequent value or most common value, so it will also not affected by the extreme value.